Hey guys, welcome to the hand calculation series. In this video, we're going to be talking about how to compute points that are actually under a block. So why do we need to know how to do this? I think it makes the most sense in the context of if you have a critical structure that is in the field. So in this case, you may want to reduce the dose to said structure, and you can use a block to do this. And so I'll draw out the geometry here. So here you can see that we have some large field, and we have a block that is placed in the center of the field because we have a critical organ that is shown here. So in this case, we might be treating, something big, like maybe we're treating the entire bloodstream and we want to shield something like the spinal cord or the lungs or something like that. But this is a situation where you might, want to use a block and shield something from getting too much dose. And so how do we actually do this? Well, it's a lot more straightforward than it is to calculate the dose to a point outside the field. So this is what we do. We just take the dose that the point would receive from the open field and subtract off the dose from the block field. So we compute the dose using the field size of the open field, and then we compute the dose for the field size of the block, and we just subtract the block field dose from the open field dose. So it's a very straightforward calculation. It's just a subtraction of two different doses using two different field sizes. And I'll just work through a quick example here, so please take a moment or two to read through the problem statement. And so we can start off by drawing the geometry that we're dealing with. So the geometry we're dealing with is shown here. We have our block field size of 5 by 5, our collimator field setting of 15 by 15, and we're calculating the dose to a point at Dmax with 100 centimeter SSD. So we're actually in the calibration condition again. We're just changing our field size. So the equation here is very simple. We just apply the PDD formalism because we're at 100 centimeter SSD, and since we're calculating at Dmax, the PDD term actually is just 1 because the PDD is normalized to Dmax. So really all we need is the scatter factor for the open field size and the scatter factor for the blocked field size. And this is the total scatter factor because the collimator and phantom scatter factors use the same field size in this instance. And now we can go to the beam data to get the two factors that we need. So we just need the total scatter factor for the equivalent square of 5 and the equivalent square of 15. So for the open field, we use the equivalent square of 15, and the blocked field, we use the equivalent square of 5. So if we plug in everything here, we get an open field dose of 206.6 centigrade and a blocked field dose of 188.6. And if we subtract the two, we get a dose to the point under a block of 18 centigrade. And so this was another straightforward example, but this same methodology, formalism, can be used in any geometry to compute the dose to a point that is positioned beneath the block. So thank you for watching.